All right, this is Mr. Wyrick. I'm going to take you through this 1.8 Venn diagrams set of notes. So this is a set of Venn diagrams. I'm sure you've used them in English class for like comparing and contrasting a couple of different things. We are going to use them for probability, and it's going to be interesting things like these people in circle A play basketball, and these people in circle B play baseball, and where they overlap is people that do both things. So how can we use them for probability? If you have 30 students in band, 12 that run cross country and 8 play football, well, 16 plus 12 is 28 plus 8 is 36. So there's too many people for 30 students in the class. There's got to be some overlap in activities. So if you use a Venn diagram, you can illustrate that. And then when you calculate probability, you can say, okay, out of everyone that plays football, how many of them also are in band? How many of them also run cross country and all that kind of stuff? So you'll be able to look at it and see what's going on. So our sample problem, Miss Lucas conducted a survey of 40 randomly chosen students that she teaches. The survey showed that 23 are in the marching band, 25 are taking Spanish class. There are 12 students in both the marching band and taking Spanish class. Try to set up this information without a Venn diagram. So this is actually kind of tough without the Venn diagram. But when we do this one, and I'm going to illustrate this on a little piece of paper over here that I'm setting up. There's 40 people that have to be in the class. I'm going to make this circle, and this is marching band. And I'm going to make this circle, and this is Spanish class. Now, it says 23 are in the marching band. It says that 25 are taking Spanish. But remember, that's everyone in this circle. And it says 12 students are doing both. So I'm going to put a 12 right here. So because it says that 23 are in the marching band, here's 12 of them already. So there needs to be another 11 out here. So now I have 23 in that marching band circle. I have 25 people in Spanish class. There's 12 here. So here's 13. That's 25 in that circle. So then when I set this up, it gives me some questions. It says, how many students are in the marching band? Sorry, got to get focused there. How many people are in marching band and not in Spanish? That's going to be these right here. That's 11 people. How many are in Spanish and not in the marching band? That would be these 13 people. How many students are in neither marching band nor Spanish? Now, we didn't answer that, but that's why I drew this block around the outside. 11 plus 12 plus 13 does not equal all 40 people in the survey that she gave out. Okay, 40 randomly chosen students that she teaches. 11 plus 12 plus 13 is 36. So there's another 4 students out here that they are not doing either marching band or Spanish. Okay, and then how many students are either in the marching band or taking Spanish class? This is where it gets tricky when you have a question like this. How many students are either in the marching band or taking Spanish class? That or is inclusive, okay? So that would be everybody that's in my marching band circle and everybody that's in my Spanish circle. But if I try to do like what the question says, 23 in the marching band, 25 in Spanish, I count those and I say, oh, there's 48. But 48 is more than I have. Probability cannot be more than 100%. So I have to look here. It's these 36. Okay, 36 out of the 40 are either in marching band or Spanish. Okay, so I did make that Venn diagram. Keep in mind this and or. How does using either of these words affect probability? How does it affect the sample size? Be sure that you add this into your notes. Or means we can include someone who fits at least one condition. Only one thing has to be right. This is going to make way more people available and increase the population size. Everyone in either circle, don't count the overlap twice. Okay? So this is everybody that was in band or Spanish, and it was here's band, here's Spanish. I just have to make sure to not count these 12 people twice. and say, oh yeah, it's 23 and 25. That's totally awesome. When it's and, that means we have to do both things. It's going to limit your population a lot. This is the overlap of that Venn diagram right there. How many people in marching band and Spanish? These 12. Okay. So our sample problem here, there were 75,000 people surveyed. How many people have all three of COPD, chronic bronchitis, or diagnosed emphysema? That's 333. What is the probability that you'll have at least one? If we're doing probability here, you have to add all of these together just once and make sure you don't count any of the overlap. The other thing you can do is the probability of at least one, we would take 70,345 and divide that by 75,000. That's your probability of not getting diagnosed. And then you just subtract that from 100%. That would give you everybody else. What's the probability of being diagnosed with chronic bronchitis or emphysema? That's everybody in this green circle right here and the ones in this yellow circle, but we're not counting these 970. Okay? Given that they have COPD, what is the probability that a person has chronic bronchitis? When you have given that, it means you restrict what you're dealing with. So we're only dealing with the people in this COPD circle. What is the probability that a person has chronic bronchitis? It's this 459, this 333 out of everybody that's in the blue circle, which is all four of these numbers added together. How many people were diagnosed with chronic bronchitis? That's everybody in this yellow circle. We add it all together. And given that a randomly chosen person has bronchitis, they're in the yellow circle, what is the probability that they also have COPD? This is that also, that's the and, so it's this overlap between the bronchitis and the COPD. Make sure that you add these to your definitions. The given that means it limits your total possible outcomes. Remember, that's the one on the bottom. We have favorable outcomes over possible outcomes. Possible outcomes is on the bottom. At least means you are only looking at possible outcomes more than or equal to the number. Okay, your work for today is going to be an assignment over Venn diagrams. It looks like this. You have to be very careful on this one. I'll try to give you a hint here for watching the video. Just like this was everybody in marching band, and this was everybody who did Spanish. This 30 is everybody who's going to be in the circle for eggplant. This 20 is everybody who's going to be in the circle for broccoli, and this mushrooms is everybody who's going to be in the circle for mushrooms. Because remember, they only surveyed 50 students. So the ones who got all three are in the middle of everything. You got to do some math to figure out what happens with this stuff in between. Okay, so you'll need a Venn diagram there and then calculate some probability. Then number 2, this is people trying to quit smoking. They use the patch, they use gum, they use a lozenge, or they just try to go cold turkey. And then again, it asks you some questions about that, asks you to calculate some probability. Tuesday, we probably won't do this because you guys have the biology exam. So we'll be looking at doing this stuff when I come back, and we're all there on Wednesday. So this is your assignment for Monday. Tuesday, we've got that biology exam. We might kind of go over a little bit of this for those classes that come in the afternoon. And then for those of you that won't see me, we'll go over this on Wednesday in the morning, and we'll move on with the schedule. Have a good day.